Assalamu alaikum. Today is the 6th lecture of software quality assurance. In the first 5 lectures, we have talked about what quality is, what are the negative consequences of having poor quality, what are the benefits of having good quality software, what are the economics and cost factors associated with software quality. And we also talked a little bit about management practices with respect to quality assurance. Today we will continue our discussion and we will introduce and discuss different topics in software quality assurance. We will have this as the last lecture of our first phase of this course. In the first phase, we would have discussed all the different foundation-related topics for software quality assurance. And in the next phase, we will take up different life cycle activities for software development, how they relate with software quality assurance. So the first thing that we will discuss today are quality measurements. Now, before we delve into the discussion, there are a couple of questions. What should be measured for quality? And how often should quality measurements be taken and reported? These are two fundamental questions that every software engineer who deals with measurement have to answer. In this lecture, we will only introduce the topic of quality measurements and we'll briefly look at different things that we can measure. We will discuss in much more detail quality metrics later in the course, but to give us a good understanding of what are different aspects of quality measurement, it is better to introduce them here early in the course and then take up the details later on. So remember the two questions that we talked about. So there are two kinds of quality measurement categories. First is the measurement of defects or errors or bugs in software. And second is the measurement of user satisfaction levels. So there are two kinds of measurements. One is the measurement of defects, and secondly, the measurement of user satisfaction levels. As far as defects are concerned, we measure 100% of software projects. That's all software projects have to take this measurement. And as far as the user satisfaction measurement level is concerned, only for software projects where clients can be queried and actually use the software consciously. So for those clients, and this is applicable to commercial software packages, especially, that many times customers cannot be contacted because there are so many customers that it is not really possible to get in touch with all of the customers and users. And secondly, it also applies to those very specialized kind of projects in which the actual users are not in touch with the software development company. And so we say that software quality measurement, as far as the defects are concerned, we have to measure them for all projects. All projects have to have some mechanism of recording and measuring defects. And user satisfaction will only be measured for those projects in which the development team or the developer is able to contact the user and get their feedback. Now let's discuss some software defect quality measurements. The first is defect volumes, that is the quantity of defects. How would we record them? We would record them by product, we can record them by time period, and we can record them by geographic region. This may sound not intuitive. Why would we want to have defects recorded by geographic region? The reason may be that some errors occur because of a timing problem, and so this may be necessary. Or some products may have different versions in different parts of the world, and by recording the geographic region, it may be easy to locate and then repair software defects. The second thing that we would like to measure are defect severity levels. How severe the defect is it crippling the system? Is it resulting in the failure of major functions or minor functions, or it is just a cosmetic problem? The next is recording defects in special categories. Now, what are these special categories? There are some invalid defect reports, there are some duplicate defect reports, and there are some situations where the reported defect cannot be duplicated again. Remember that we talked about testing as a mechanism of trying to find errors by observing failures, and this sort of situation happens that in one particular scenario a defect occurs, but when test engineers try to recreate that scenario and see the defect for themselves, they are not able to do that. And for a software defect to be removed, they have to recreate that themselves also, to see what were the inputs, what were the outputs, and where the failure occurred, so they can observe it themselves and then correct the problem. Then one would also want to record the defect origins, which can be requirements, which can be design, code, some documents, or some bad fixes. And so we had talked about defect origins earlier in the course. We would also like to record where the defects were found, that is, defect discovery points. Defects can be discovered as a result of having reviews or inspections. They can be discovered while performing testing, and there are a number of testing techniques: unit testing, system testing, integration testing, acceptance testing. Or they can be found in customer reports. And so we also have to know and record what was the discovery point for a defect. We would also want to keep a track of and measure defect removal efficiencies. Remember, we said that high defect removal efficiency is an indication of high quality in software products. And best in the class companies have very high defect removal efficiencies in their software, in their best software projects. And we would also like to record normalized data, that is, defects per function points or per lines of code, per kilo lines of code. I would, however, like to briefly mention that use of lines of code as a mechanism is not very good. lines of code measure is quite a bit deceiving, as you will learn during this course. And another thing that you would like to record is the causative factors. What are the reasons why these defects were found in the software? Are they because of complexity of the application domain, or complexity of the code, for example, or complexity of the design? Are these creeping requirements? Are these requirements changing very often? And so you would like to know why this defect or all defects found their way into our software work products. And finally, we would also like to record defect repair rates. That is, how quickly we can fix the problems after they have been discovered and reported. Now, this was a discussion on software quality defects. Now let's look at software user satisfaction quality measurements. What are different things that we would like to know about, and what are different things that we would like to record and keep track of from the user satisfaction perspective. So the first thing we should know is the user perception of quality and reliability. First of all, we have to understand what the user thinks about quality and reliability. Next thing we would like to know is the user's perception of features in the software product. The features that we have added in the software product, what does the user think about? Does the user really want all of them, or does the user want a large majority of them, or the user does not want a large majority of them? For example, if you take any word processor, commercial word processor package that is available in the market, an ordinary user will not be using a large number of the features available in the in those tools, in those software products. And the third thing you would want to know is the user perception of ease of learning. How easy it is to learn a software product. That's very important because many products can be ignored by users if they're very difficult to learn. And whenever, even for professionals, whenever we talk about a new technology, we always have to incorporate incorporate timing and other resources for learning new products. That is one thing about learning. The other thing is you have to know the user's perception on ease of use. It's one thing you learn something, but how easy or how difficult a product is to use. Because once they learn it, they have to use it on a regular basis. So that's also very important. You also have to record the user's perception of customer support. What does the user really think about the support given by the developer, or the support given by any of the third-party companies which have signed a contract to provide support for different products. And another relevant point that goes with the customer support is the concept of speed of defect repairs, and you have to see it from customer's point of view, from the user's point of view, because in many cases the defects will result in shutting down of the software system. And when the systems are shut down, the users are not able to perform their work, and as a result, every minute wasted is a burden on the company, is a burden on the economy. And so the developers would want to think that they have quickly fixed the problem, but that may not be as fast as what the users would have wanted. And so user perception of speed of defect repair is also a very important quality measure with respect to the user satisfaction. Let's continue our discussion on user satisfaction quality measurements. Another measure that we as software companies have to worry about is the user perception of speed of adding new features. That is, a customer would say that we want these new features added, and how quickly does the development team add those features into software is also a thing that should be recorded from the user's perception, from the user's perspective. And if you are blessed and there is no competitor in the market, then you may not worry about these things. But if there are competitors available in the market, then you also need to know what the users think about those competitors and products which are similar but offered by the competitors. This will help you in adding more features which are liked by the user and providing those services which the competitive products provide and are again liked by the user. And there's another very important quality measurement that is really the crux of the matter, and that is what the user thinks about the value that it gets from the cost of the software package. And so user may wonderfully like the product but thinks that it's too expensive, or thinks otherwise, that it is such a good product that this kind of high price is also justified. And that ultimately would help other similar users and customers to buy your product, because happy users and happy customers naturally lead to better market share in software products. Now the question is, who measures user satisfaction? Because we have discussed quite a few of user satisfaction quality measurements, and if a company continuously does that, it can become a burden on the routine work of the companies. So there are a number of options that can be used to collect and record user satisfaction quality measurements and user satisfaction quality factors. So the first is marketing or sales organization of the software company. That's the obvious one, that the marketing and sales people are always talking to the customers and users, and they will be able to collect that information from the user base. Then there are user associations. Also there are software magazines, and a large number of magazines are published every month, and that information can then be collected from those magazines. Then there are direct competitors. They also collect and sometimes publish their promotional material on the web and in magazines, and that can be used to look at the satisfaction levels of the customers, as sometimes they compare their products with other companies also. And there are user groups on the internet and other sources, like they can have different kinds of group meetings, user association type things. But everything is going on the web now, so you can have blogs in which different users can come and describe their satisfaction levels with respect to a software product. And then if they are paid, if they are customers who actually are using the product, then the company can analyze those blogs, because with the web everyone can join and express his or her opinion. So with this kind of information, there has to be some sort of filtering done in order to get to the truth of the matter. And there are third-party survey groups where companies actually pay third-party companies to perform surveys. And these third-party companies are actually experts in conducting surveys. And they contact users of different products and get their opinion about it. And but one thing is important, that in many cases, companies would have to do this, spend some money and find what the user satisfaction levels are with respect to their software products. How would you gather user satisfaction data is focus groups of customers. You can use the formal usability laboratories. This is common in telecom industry. Then you can use the external beta testing to get the data about the users from the users. You can get requests from the user associations for improvement in usability. Then you have imitation of usability features of competitive or similar products by other vendors. And so that way you can get the information that what kind of user satisfaction feedback is being provided. Now, we have briefly looked at quality measurements. But the problem is that the industry has not adopted quality measurements as a mechanism and as a full-fledged activity in software development projects. Why is that? There's lack of understanding of need to measure quality. Often, technical staff shies away from getting their work measured, and that is a problem because they are not fully aware of the usefulness of measurement themselves. And historically, industry has been using lines of code and cost per defect metrics, but they are poor way of measuring software quality. And we will talk about quality metrics later on in the course in quite a bit of detail. There's another thing which all of you are familiar with, and that is the object-oriented technology. Object-oriented technology is adopted worldwide with a claim that it produces high-quality software products and that it produces reusable software code. One thing you have to remember is that object-oriented technology has a steep learning curve, and as a result, it may be difficult to achieve high-quality software if proper care and training is not provided. Proper education and training and careful design and code. We need to look at more data. So researchers and companies have to report their experiences with use of object-oriented paradigm in improving software quality. And so we cannot just accept a claim. We have to look at the look at the data before one can reach a conclusion. There is another topic which relates with the reporting of software defects. The traditional way of dealing with software defects was to simply aggregate the total volumes of bug reports, sometimes augmented by severity levels and assertions as to whether defects originated in requirements, design, code, user documents, or bad fixes. There is another way of reporting that is known as orthogonal defect reporting. In the orthogonal defect classification, that's the ODC method, defects are identified using this approach. First of all, you have to record the defect detection method. Was it design or code inspections or any variety of testing steps? Then it has to have symptoms, that is system completely down, performance downgraded, or documentation, or questionable data integrity, that is output may not be as expected. Then you have to have type, which is interface problem, algorithm error, missing function, or documentation error. So the defect type has to be recorded with it, as also the trigger. Was it a startup or heavy utilization, termination of application, or installation? Where did the error occur, or what triggered this defect to occur? And then you have to have the source, which is version of the project using, normal configuration control identification number. And so in this way, there is more information with the defect reporting, and as a result, it is quicker to get to the real cause of it. See, we only have mentioned symptoms here. We don't know what the real cause was. And when we have these sort of information with us, we can try to find the cause and remove it from the software work product. Now let's move on to another interesting topic, and that is outsourcing and software quality. As you know, outsourcing in software development has become very popular. A company gets or wins a large project, it specializes and is expertise in some of it, and then it asks other companies to join in and develop parts of it. That's outsourcing. This goes on within the country, and the outsourcing projects are given from different countries to different other countries, that is companies in different other countries. So it's a global phenomena. There is a global outsourcing activity going on in the software industry, and quality has to be a top priority when outsourcing, because although the prime contractor or the developer, main developer, or the client ensures that quality is of number one priority, but still the processes and the development methodologies and practices of the subcontractor have to be continuously monitored, and no compromise should be allowed in the execution of these practices and procedures. So quality itself is a challenge for software development, and when we have outsourced projects, this becomes an even more interesting and even more challenging task to maintain high quality products. And within the contracts, the main development organization or the client or the prime contractor should record the kinds of quality metrics it requires the subcontractor to record, to report, and to measure. And so this is itself a very interesting and very complex topic that needs to be formalized in the writing of the software contract. Let's look at some of the other areas in software quality. Estimation is another very important area in software quality, and remember we talked about the use of estimation with the help of software tools to predict defect potentials and other things. So now we discuss what kinds of estimation is necessary for large projects, for complex projects. Estimating or estimation of defect potentials in 5 categories, that is requirements, design, coding, documentation, and bad fixes. These are the 5 ugly categories where defects can originate. Then we have estimating defect or estimation of defect severity levels into 4 categories. We talked about 4 categories of defect severities, from level 1, which is a total catastrophic failure, to level 4, which is minor or cosmetic error. So we should estimate that the number of defects falling into level 1 to number of defects falling into level 4. We should also estimate the defect removal efficiency of various kinds, reviews, inspections, and a dozen kinds of software testing. We have lots of like unit testing, like integration testing, acceptance testing, system testing, regression testing. And so for each kind of software testing, we should estimate what would be the defect removal efficiency. We should also estimate what kind of or what number of defects would still be present in the software application when it is given to users. So with that we can allocate resources to the repairs when a defect has been reported by the customer. Estimating the number of user-controlled defects on an annual, user-reported defects on an annual basis for up to 20 years. Obviously, this applies to very large projects where the life of the software project continues on and on. And with this kind of data, we can not only improve our quality attributes and quality processes in the coming and future projects, but also have better estimation concepts and estimation skills applicable to the next for the next projects. Obviously, if the project size is not very big, it's an information system type project which can expect to last long, but not that long. We do not have to record this type of information. The purpose here is not to burden the development company with so much data that it becomes a problem to do the real thing, which is to produce high quality software. The purpose is for these things is to help the developer or the development company to improve their processes and to improve their products. And another important thing that must be estimated is the reliability of software at various intervals using two metrics. Number one is the mean time to failure metric or mean time between failure metric. So these are two metrics which are used to measure reliability, and whenever you see a software product or any other product which says that this is 99% reliable or 100% reliable or 95% reliable, that reliability is measured using these two metrics. There's another thing that whenever, especially in large projects, especially in very large projects, whenever there's a production and customer starts using the software product, it takes a little while before everyone gets used to it and everyone fully understands it. Although before the production begins, the users are given training, the computers are provided if it's a switch from the manual system, but still there has to be some stabilization period that can be a couple of weeks, that could be a month, maybe longer, maybe fewer, that would be required for everyone to come to speed with the new system and come up to speed with the realization that yes, we are going to have a new software system which is going to do lots of good things for us. And so this stabilization period has to be predicted, and this depends on the number of users, how committed the management is, how well the training was conducted, and so forth. So but there has to be an estimate, because once that stabilization period is over, a large number of users should be able to execute their applications without encountering severe errors, without encountering errors which are going to shut down the systems. And you also need to estimate the efforts and costs devoted to various kinds of quality and defect removal efforts, such as inspections, test case preparation, defect removal. We had talked about these things in costs, but you need to estimate them beforehand. You would also want to develop an estimate for test cases and test runs for all testing stages. You also want to have an estimate, depending on the project size again, the special kinds of defect reports, including duplicates and invalid reports, which trigger investigative costs but no repair costs. So there's another thing, that if a defect has been reported and it is not a defect, but at some time has been actually spent on trying to find a software error which is not there, and so there is a cost involved with it, and there is no repair cost because there was nothing to be repaired in the first place. And sometimes these investigative costs are a little bit higher, not in terms of comparison with the repair costs, but these are costs which go sort of in waste because there is nothing that comes out of it. Now we will talk about, again briefly, on function point metrics. Function points were developed at IBM and they were reported to public in 1979. Function points are a way of determining the size of a software application, mostly information systems, by enumerating and adjusting 5 visible aspects that are of significance to both users and developers. So there are 5 significant aspects which are visible to both user and developer. We'll see what those 5 aspects are. Number 1, there are inputs that enter the application, that is input screens, input forms, commands, etc. Second, there are outputs that leave the application. There are output screens and reports and the like. Then you have inquiries or queries that we call them more often, that can be made to the application, that simply said queries for information. Then there are logical files maintained by the application. There are tables, text files, etc. And finally, the interfaces between the application and other applications, that can be shared data, that can be messages, etc. So these are the 5 aspects that are visible to both the user as well as the developer. And without going into much detail about function point metrics and how they are calculated, I'm just going to give you a brief overview of what they are, because they have become now the main source or main metric of measuring software applications, the size of the software application. So once the raw total of all of these 5 factors have been enumerated, that is calculated, then an additional set of 14 influential factors are evaluated for impact using a scale that runs from 0 to 5. 0 would mean this factor has no impact, and 5 would mean that it has a major impact. And so in addition to the 5 major factors, we have 14 other influential factors. And some of these factors may not be applicable on every application. And we will talk about, and then with the calculation of these, application of these influential factors, we come up with a number, and that would then help us in determining the total number of function points in that application. Now, once we have that number, we can then say that the total cost related to defect prevention was this in this application, and the number of function points in the application is so and so. So we have cost of prevention per function point, cost of defect removal per function point, and so forth. And then we will have a normalized data, as we had talked about before. What function points provide us is a normalization of data, because we are applying first 5 factors and then additional 14 factors to it, and then we can then that would be the size of the software application. Function points are a very interesting and very and a topic which is growing, and companies are using function points now. They have become the leading mechanism for determining for recording the size of the software application. We will talk about function points later on. Let's talk about another very interesting topic, and that is litigation and software quality. A customer can take a development company to court for breach of contract if they disagree on the claims that have been, or the contract that has been signed between the 2 parties. We hear quite a bit in software quality terms like efficiency and flexibility, portability, reusability, interoperability, and security, and things like that, and also correctness and testability and understandability. These are terms, most of them, which can have which can have multiple interpretations. And unless you actually define what the word or phrase means, these can be misinterpreted or intentionally or unintentionally. And there can be consequences for that. And as we are becoming a society more and more dependent on software services, the possibility of litigation has increased also. In the first world, this has increased substantially. Even in other countries, there are cases of litigation. So let's now talk about what are the relevant factors for software quality. Relevant factors for software quality. Correctness is a relevant factor for software quality. Reliability is a relevant factor for software quality. But we have to define what correctness is. We have to define what reliability is. And remember that we just talked about mean time to failure and mean times between failure as two measures used to define reliability. Then we have integrity. We need to define what integrity is. Usability. We need to define what usability is and ensure that our users understand that also. Then we have maintainability, which is also a relevant factor for software quality. We have testability. We have understandability. So these are the things which are relevant for software quality. Now the factors which are not relevant for software quality are efficiency. How would you define efficiency? You need to define it very clearly, but only the word efficiency is not going to work. Flexibility, no, don't use the word flexibility in the contract. Portability does not apply to quality. Reusability does not apply to quality. Interoperability does not apply to quality. And security is not applied to quality for contracts. If we put them in the contract, there's a possibility that the customer can take the development team or development company to court for breach of contract. It is important to narrow down the scope of quality definition similar to hardware warranties. If you look at the hardware warranties, that's how our software should be written. Now that makes it a little bit difficult also for software professionals and companies, because we have to define what correctness is, for example, and then apply the correctness and reach the correctness definition. Another topic on software quality is schedule pressure. Healthy pressure motivates and keeps morale of the personnel. On the other hand, excessive pressure has serious negative consequences on the morale of the personnel, and it can lead to low quality software. And we had talked about excessive schedule pressure earlier in this course. Now let's briefly talk about the project lifecycle quality assurance activities. Project lifecycle quality assurance activities are process-oriented. In other words, they are linked to completion of project phase, accomplishment of project milestones, and the like. The quality assurance activities will be integrated into the development plan that implements them. One or more software development methods. We have a number of software development processes, like waterfall model, there's prototyping model, there is spiral model, and there are other models also. And so we have to incorporate the project lifecycle quality assurance activities in each of these process models. And so the SQA planners for a project are required to determine the list of quality assurance activities needed for a project. So what they require for this project, they have to list it down. And this list would then come from the SQA plan. And for each activity, you need to list the timing, because nothing gets done without spending some time on it. Who performs the activity and the resources needed. So the doer and the other resources that are needed. And resources required for removal of defects and introduction of changes. So unless we document this clearly, there is a good possibility that these things will not get done, or these things are going to delay the project, and the time allocated for quality assurance activities and the defect removal will then be blamed for the delay in software projects, and that's not good. The intensity of software quality assurance activities planned indicated by number of required activities is affected by project team factors. There are project factors and team factors which I will mention to you before we end this lecture. The project factors include magnitude of the project, they include technical complexity and difficulty, extent of reusable software components, and severity of failure outcome if the project fails. So these are the project factors. The team factors are professional qualification of the team members, team acquaintances with project and its experience in this area, that is how familiar the team members are with the business area, with the application domain, availability of staff members who can professionally support the team. There are a lot of other non-technical stuff that needs to go with the software development effort. That is a non-technical staff, how much support they can provide. And lastly, familiarity with team members. That is, what is the percentage of new staff members in the team? Because we need to have a gelled team, a team which can communicate well with each other. Today was the last lecture in the first phase of this course, and today we have discussed different topics on software quality assurance. From the next lecture, we will take on the quality assurance as it applies to different life cycle activities in the software development process. See you in the next lecture. Bye.